Hey team, Andre from High Performance Academy here. Welcome along to today's webinar. And today we're going to be diving into the world of PID control algorithms and how we tune them. This is the backbone of essentially any closed loop control strategy. You're going to find it applied to many aspects of today's factory and aftermarket ECUs. I'm talking here about aspects such as continuously variable cam control, boost control, and idle speed control, just to name a few. It is something that a lot of even experienced tuners really struggle with getting right. They don't understand how the system works. So today we're going to dive deep into the process and we're going to go through a demonstration so you can see how each of the components of the PID control algorithm actually affect the operation. We're obviously going to be using our Toyota GT86 for this demonstration. It's fitted with a Motec M150 ECU, and specifically we'll look at the cam control tuning simply because it's really quick and easy for me to demonstrate. However, everything we'll look at will also be 100% applicable to any other aftermarket ECU. Before we get into that though, just to cover off what has been going on around HPA Labs over the last couple of weeks, and the first one I wanted to talk about is we are running a special. So this has only got 5 days to go, so if you are actually watching this as a recording on our YouTube channel, you may have missed the boat, but for those who are watching live, you definitely haven't. Let's head across to my laptop screen, and if you head across to hpacademy.com/course, you will find this little pop-up banner up the top. It says enroll now. This is a 50% deal off our most popular wiring course, which is our practical club level wiring course. I'll just take you through this quickly. Again, you can go through this at your leisure if you click on that link. But our club level course is normally $229 US. For 5 days left with the special, we are doing it for $114.50 US. You can still use our payment plan option with that as well. That allows you to break it down into 8 individual weekly payments of just over $14 US. You will get instant access to the course the second your first payment has processed, so you don't need to wait 8 weeks before you start learning. So this course carries on from our wiring fundamentals course. It would be great if you already had that course. If not though, a lot of people coming into wiring will already have some base level knowledge, and this course essentially assumes that base level, so you will need that to get started. And what it does is it dives deep into the practical skills that you will need to understand in order to build your own wiring harnesses, deep into the design process behind the wiring. And what Zach's done within this course is broken the entire wiring task down into a simple 8-step process. And we think this is really important because we know a lot of enthusiasts who are really happy to get involved in just about any other aspect of their own automotive projects at home tend to get scared off wiring. And I think part of this is because when it comes to wiring, it's a little difficult for us to understand what's actually going on in a circuit. We can't see voltage, we can't see current, and we can't see resistance. And I believe this is what puts people off. So this course will break that down. You'll learn exactly what's going on in the circuit. You'll learn about the power supply design, the grounding design. And as I've said, it's broken down into an 8-step process. Each of those individual steps of the process is really quick and easy to complete. And in no time, you've got a completely designed, a completely built wiring harness. You're going to have the confidence that it will be exactly what you wanted. It's going to be tested. You know, every conductor in the wiring harness is going exactly where it should. You've tested all of that so that when you power that up for the first time, are you going to understand that everything is going to work exactly as you'd expect. I'll just quickly go over some of the key aspects. So the practical wiring harness design skills, this is a really key element with this course. So many people just jump into a wiring job with a few spools of wire, some side cutters and some wire strippers and get stuck in. And we have a saying at HPA that failing to plan is planning to fail. So a big aspect of this course focuses on designing your harness before you actually ever pull out a roll of wire and the side cutters. We talk about component inspection and mounting, the power and ground supply design, sensor and actuator designs, network communication design, just to name a few. We then get into our practical wiring harness construction skills. So we talk about wire preparation, splicing our supply and ground wiring together, splicing to shielded braid, bundling and branching, again, just to name a few. We've got of the eight-step process that I mentioned here. This actually follows through a real wiring job, so you can see this being put to use in the real world. Again, it's also worth mentioning here that while in this course, Zach uses the 8-step process to produce a wiring harness for our own FD RX-7 project car. It's applicable regardless what you're trying to wire up, whether it's an aftermarket or a factory ECU. Maybe you're just wiring up the chassis harness for your vehicle, your headlights, your tail lights, fuel pumps, thermofans, those sorts of things. Doesn't matter. Everything in this course is 100% applicable. I should also mention, because it is called the Practical Club Level course, it's designed around cost-effective materials and tools. So it's not going to cost you the earth in order to produce a really high quality and reliable harness. Might be a little bit heavier than a professional motorsport course, and it's probably not going to have the flash and expensive Autosport connectors. It's going to get you a very adequate result, very reliable result. So again, that deal is only running for the next 5 days. So head across to hpacademy.com/course. You'll see that pop-up banner at the top. Click on Enroll Now to take us up on that package deal. Now, if you have been watching over the last few weeks, you'll know that last time we ran one of these webinars, I mentioned that we were prepping for another engine building worked example. This time we were building a Mitsubishi Evo 9 4G63 with the intention of making somewhere in the vicinity of about 700 to 800 horsepower. Nothing particularly crazy. We're sticking with a cast iron block, and we are using a billet 2.2 litre crankshaft. I'll jump over to my laptop screen. Got the opportunity last week to film the first couple of modules of this, and one of the aspects here is disassembling the base engine components and seeing what we've got to deal with. This is always a little bit of a mixed bag, particularly when we're dealing with an engine that we don't know the history of. We're hoping that we've got something that is in good condition, even though we are replacing a lot of the components here. I generally like to see an engine that has been well looked after, and we can see here I've just got one of the bearing caps off, and this is one of the inspection tasks that I tend to go through when I am stripping an engine. It's always a good idea, even if we aren't reusing these components, just to be a little bit vigilant and inspect everything as we disassemble it. And what we can see here is an engine bearing that, in my opinion, is actually in pretty good condition. We can see some really minor scoring, but this is pretty typical. Anything that's done a few miles, you're likely to end up with some small amount of debris going through the oiling system, and that's going to result in these radial lines, which we can see on the bearing surface. Particularly what we are looking for here that would be a worrying sign is anything where we're seeing copper color on the bearing surface. This means that the bearing is starting to basically fail or disintegrate, and we're basically one step away from failure. So the other important aspect to mention here is we are at the moment inspecting the cap. There's a lot of valuable information that will come from the bearing on the cap, but because this is on the underside of the connecting rod, this is the less highly loaded side of the bearing shell, so it's always a good idea as well to inspect the bearing shell that sits on the body of the connecting rod, because that's the one that's actually being forced down under high load during the power stroke, so that's the one we actually want to inspect more thoroughly. Another part of this as well is we also want to have a bit of a visual inspection of the condition of our crankshaft journals, both the big end, which we're looking at here, as well as the main journals. Now, there's a little hard to really tell too much here. This journal is actually in really good condition, and a little simple test that you can do here is just run your fingernail across the surface of that journal. Generally, if you've got any ridges or scores that you can actually feel with your fingernail, that's indicative that there's some damage there to that journal that's going to need to be polished or sometimes even ground. Now we can see there's some what looks like light scoring. It's actually nothing. It's more of a visual aspect than anything. Run my fingernail across that. It's absolutely perfectly smooth. A very light polish, and that would come up looking like brand new. So we've got an engine that is in pretty good condition. That's also indicated, you can see little bits of it here by the color of the oil here. When we pull an engine apart and we're not seeing sort of black coked up sludge in the SAM pin on the components, this is always a good sign, and it indicates that the engine probably has been looked after, at least had thorough oil changes. So again, just a nice honey glaze color like that, indicative that the engine has been pretty well looked after. So we've got everything filmed there. We'll get that engine away to our engine machinist fairly shortly. Not a lot of work to do there. They're going to be basically boring and honing the block to suit our new JE forged pistons. These are a 0.5 mm oversize, 20 thousandths of an inch oversized. Just gives us enough material to remove from the bores to allow any wear in the bores to be cleaned up and give us a nice perfect round finish, as well as a nice fresh home pattern for the rings to bed in on. We will also be using a torque plate during the honing process. We're using an ARP Custom Age 625 Plus stud in the factory 11mm. That provides a lot more clamping load though than the stock head bolts, and what this can do is distort the bores slightly when they are torqued up. So we want to torque plate hone the engine block, and that way we're getting rid of that, or replicating that same distortion when the studs are tight. So theoretically what this means is when the head is bolted on in place, we're going to have the perfect round bores, which allows our rings to do a better job of bedding in. And now in other news as well, we've got a few updates on our Toyota 86 with the SR20 VE turbo engine in it. We're actually destined to hopefully head to the racetrack at the end of this week, weather permitting. It's actually not looking too good at the moment considering we've got snow on the ground outside, but we are going to undergo a 1 hour test if the weather does play ball. And this is basically a systems test. For those who have been following, you'll know that we attempted to get this car up and running in a remarkably short amount of time before our endurance racing season last year. Didn't really work out for us. We really tried to do too much in too short a time. So we've got the opportunity now to regather, regroup, and get everything thoroughly tested. One of the problems we did have last season was problems with overheating. Basically our cooling system wasn't up to the task, and we really want to just head to the track and make sure that everything is working there with the cooling system. Before we jump into the cooling system though, one of the other changes which we've got on my laptop screen at the moment is to the ignition coils. And previously we had, I don't actually have a photo of them, but previously we were running a set of Nissan R35 GTR coils on a CNC machined aluminium mounting plate from EFI Solutions in Australia. They were a good solution for a street car. However, considering the P11 Primera rocker cover really wasn't designed for a coil-on plug installation, it used a distributor with ignition leads. It's really difficult. There really is only one mounting hole that could be used to pick up for the coil mounting plate. And particularly in a race application, the physical aspects of removing the coils to remove and replace spark plugs or even check the plugs was a real pain. We couldn't do it quickly, and just in my opinion, not something that was a smart option for a race application. So what we've done is we've gone to a set of the fairly well-proven IGN-1A coils. They're cheap, they're cost-effective, they do a good job, and they put out high spark energy, also really easy to source replacements. Mounting the coils though, I didn't want an ugly mount hanging out over the fuel rail or the plenum chamber, and we wanted something nice and reliable. So Jimmy, our fabricators, actually shaved down the factory SR20 rocker cover and mounted them directly to the cover. They actually still clearances the camshaft, if anyone is wondering. Yes, we did think about that. So this is what that looks like in the engine bay. So you can see we've got individual leads running off this. The way that we have angled those coils allows us to remove and replace the ignition lead as well as a spark plug without needing to remove the coils. And you can see at the moment Brandon is in the process here of making up an adapter wiring harness. At the moment we're waiting for some parts. This is sort of a temporary solution, which is why you can see we've got 4 DTM connectors up here. Ultimately Brandon is actually going to build this junction box, which looks a little bit elaborate and probably, in all fairness, is a little bit elaborate, but it's going to be a nice reliable solution to adapt our existing wiring up to suit the IGN-1A coils. So this should give us a rock solid solution for our ignition system that is going to be up to the demands of race use. Now back to our cooling system. A little bit hard to see here. This is actually the back of the oil cooler for our transmission, our TTI 6-speed sequential gearbox. So this is on the right hand side of the car. We're actually looking forward from the right hand side wheel well. So it's a carbon fiber duct. Got another picture of this. Is one here that I'm about to show the other side of. So this was laid up, a wet layup over a mold that Brandon and Jimmy produced. It's carbon fiber. The surface finish you can see there is due to the fact that it's been laid up with peel ply and it's been vacuum bagged. So this just absorbs any excess resin out of the finished product. And this is that finished product. Not too sure how easy it's going to be to see. We've got a nice smooth surface on the inside, which is what we really care about in terms of airflow. So this basically mounts to the back of the cooler, and then if If I turn this around, on the other side, we've got the end of the duct, which comes out through the front bumper. So a little bit of work left to do, particularly in the outlets. We need a little bit of a lip on the front of that to create a low pressure area that's actually going to allow the airflow out. And this is really one of the key things we wanted to test. We had been seeing our temperatures creep up over even a 6-lap sprint race, so I'm not entirely confident yet that we're on top of our cooling problems, but given that we didn't have a proper outlet from those ducts previously, really keen to test that and see how everything works out. So if we do get a chance to get to the track next this Friday, we will obviously update everyone in time and let you know how all of that goes. I just wanted to mention a Instagram that I put up just recently, and this is a really common topic. We've talked about it before in our members webinars, which is the topic of head gasket sealing. It becomes a really big issue when we are pushing high boost pressure, and there are a variety of solutions out there. There's a lot that do work, so it's not a situation where I can say this is the way that we must do it, but it's interesting because this is the technique that top fuel drag engines use. These are about the most powerful engines we're likely to see. So if it's working for them, chances are it's a pretty bulletproof solution. So we can see this is a cylinder head for a Toyota 1FZ FE. So this is, off the top of my head, I think a 4.5 litre straight 6. This is actually off a sand drag engine from Dubai. This is producing around 1700 wheel horsepower on methanol, running 70 plus PSI of boost. And what we can see here, it is a little bit tricky, but you can see we've got this stainless steel wire O-ring, and that is recessed into a groove around the outside of the combustion chamber in the cylinder head. So basically the machinist here will machine a recess or an O-ring groove into the cylinder head. That wire normally in the region of about 0.9 millimeter in diameter, and the O-ring groove in the cylinder head is designed for a slide interference fit. So essentially the stainless steel wire actually is a tap fit into that groove. Once it's in there, very difficult to extract. A little bit fiddly as well, just file fitting the ends so that they do butt together nicely. So that on its own isn't really going to be enough. There will also be a receiver groove that's machined into the top of the block, and it's directly in line with that stainless steel O-ring. And the idea here is that we use this in conjunction with a copper head gasket. The copper material is relatively soft, particularly if it's been annealed, and when the head is bolted in place, the protrusion of that O-ring will actually force or deform the copper head gasket down into the receiver groove. So it kind of locks the head gasket down into the block, and it provides a really stable path, that a stable lock that's very difficult for combustion gas to escape through, even if the cylinder head does lift marginally. There's no free lunches here though. Copper is unfortunately a horrible material for sealing water and oil, and particularly in most of our street car applications, we're going to have oil and water galleries running between the engine block and the cylinder head. So that's something that does need to be considered. There are a variety of solutions around that as well, but definitely something you do need to consider. For those who aren't currently following our podcast, we'd really appreciate it if you are a podcast type person. If you would subscribe, really help us. The more subscribers we get, the easier it's going to be for us to grow our podcast. That'll allow us also to get more guests along and bring you guys more detail, more free information. If we head along to my laptop screen here, hpatechtalk.com is the place to come if you want to see a full list of our podcasts. You can listen basically anywhere you already listen to podcasts. Our latest podcast that just recently released, we talk about the Tilton Evo Time Attack car. The Tilton Evo, for anyone who has followed Time Attack, is really popular. It's done a lot of winning at Time Attack over in Australia, and unfortunately the original version 1.0 got written off not that long ago. For Time Attack back in 2019, before the world shut down thanks to COVID, they did rebuild, or they didn't rebuild the original Tilton Evo. The chassis was too badly damaged, but basically built version 2.0. Particularly here we dive into the details details of the engine, which is a 4G63. This is still a cast iron block, which is relatively rare at the top end of the open class at World Time Attack. Almost everyone now is running a billet block. This one is making 1200 horsepower out of a 2.2 litre stroker engine, and we find out what makes that tick. So if you're interested in learning a little bit more, go and have a listen to that podcast. Lastly, we'll just also head over to our YouTube channel and the latest release from us. This really goes along with our recently released variable cam control tuning course. One of the aspects with variable cam control, it's not just a case of optimizing the power and torque from our engine. It also has a big impact on the engine emissions, and this is something that maybe we don't consider too much in the aftermarket, but particularly if you're working in a part of the world where you do need to meet emissions standards, this can be a really big consideration. So in this, we'll talk about how the cam timing affects emissions. We'll actually go through a real live demonstration as well, using our mainline dyno and a 5-gas analyzer. Specifically, they're looking at how the cam timing under steady state conditions will affect our oxides of nitrogen or our NOx emissions. So if you're interested in learning a little bit more about that, head over to our YouTube channel. Make sure you subscribe while you're there. If you enjoyed that video, give us a thumbs up, and if you've got any questions, please ask those. We always do our best to answer any questions on our YouTube videos. All right, we'll finish off there just by giving you another reminder. Only 5 days left for that discount on our wiring course. You can head over to hpacademy.com and you will find a pop-up at the top of the page. Click on that and you can enroll on that course. I should also mention, even with that discount, $114.50, you still have the benefit of our 60-day no questions asked money back guarantee. So absolutely no risk giving that course a test drive. Alrighty, give me a few moments. We'll get stuck into today's lesson.
If you like that video, make sure you give it a thumbs up, and if you're not already a subscriber, make sure you're subscribed. We release a new video every week. And if you like free stuff, we've got a great deal for you. Click the link in the description to claim your free spot to our next live lesson.